All right, hello everybody. Here we go. 3.2 applications of growth. All right, we got the killer plant here. Strikes Lake Victoria. Poor Victoria. Sorry about that. All right, here's Lake Victoria on the map, and let's see what's going on here. So we have this lake, this ghost lake. So read this blurb. Take a minute and read this to yourself. Pause the video, all that good stuff. All right, but once you pause and read this, all right, I'm going to highlight some stuff. The Ghost Lake is 25 million square feet. So on top of the lake is 25 million square feet just in the surface, not the volume. And at present, right, so I'm going to highlight this piece at the present. So we're going to talk about what that means. The plant covers 1,000 square feet. So hopefully at the present, you're thinking something along the line of initial value here or your y-intercept, right? So if we go back to our graph, our function f of x equals a times b to the x. This a is the y-intercept. And if I lost you so far, I put up another video that is not on these worksheets I gave you. It's called the exponential function basics. I talk about what the a value is. I talk about what the b value is. Make sure you go back and watch that video first, all right, just to get a little piece of what's going on here. So we got the initial value here at 1,000 square feet. So this plant is covering that so far, and something's going on that the area covered is doubling every month. So double, double, double. That means that is your growth rate. All right, and you remember, and from that video, the growth rate is also known as the base of the function, and that's going to be the b value here of this equation. All right, so this paragraph has given us enough information to write the equation. So in this packet, we got numbers 1, 2, and 3. We'll come to the table in a second, but we have enough to write the equation. So f of x equals, we said we have 1,000 square feet to start, and then the doubling piece is going to be times 2 to the x power. All right, so there's our equation. Beautiful. So write the equation of the exponential form. Number 2, check. All right, we have a y-intercept, initial 1,000 square feet. We have it's doubling every month, so the growth rate is times 2. All right, so what does that mean? So our month 0, what is the initial square feet there? And it is 1,000 square feet of this plant starting. So again, if you watch that video, we have 1,000 times 2 to the x power, and the video is the exponential growth basics. 2 to the 0 power, you now know, is 1, and 1 times 1,000 is 1,000. We could do f of 1 in using this equation, so 1,000 times 2 to the first, right? 1x is 1, 2 to the first is 2, 2 times 1,000 is 2,000, and again, we could use our equation over and over and over again. But since we have a table up there, let's make use of this table. But if I did this one more time, 2 squared, this is 2, sorry. Remember, this number goes in here, it gets plugged in for x. So I plugged in zeros, as 0 goes here, 1 goes there, 2 goes there, 2 squared is 4, 4 times 1,000 is 4,000. All right, and again, the growth factor is 2, so you know that each time you increase by 1 on the x, your y's will double. All right, so follow that pattern all the way down. Every time you go down the next value, every time your month increases, the area of the lake that's being covered also increases by a multiple of 2. All right, so we have our table, we have our graph, and let's move on and see what else is in here. So explain what each information of the variables represents, and we just did that already. Okay, so we did the f of x equals a, that's my y-intercept, times b to the x, and that's my 2, and which is my growth rate. All right, so we have that so far. Again, pause if you have to pause, rewind, all right, and see, make sure you got all this. All right, so the next piece here is make a graph. So I numbered 1 through 10 here. I know my graph goes up to 32,000, so if you wanted to, I guess you can count by 2s as well. So I'm going to erase this, and why not, let's count by 2. So 2,000, 4,000, 6, 8, 10, 12, 14, 16, 18, 18, and 20. That's still not going to reach my entire graph, but we'll go for it. So 0 months starts at 1,000. Okay. Notice that I'm only in the first quadrant here. All right, and if you're wondering why, hopefully you can think about what my x value is, and the x-axis. The x-axis is months, and you can't have negative months here, right? Otherwise, I'd use all 4 quadrants. All right, so we can't have negative months, and we can't have negative square feet. So we're going to be restricted to the first quadrant, and we'll talk about the domain and range shortly. All right, let's finish that graph there. So if you're looking at that table from the previous slide, all right, we got 0, 1, all right, 1, 1,000, 2, 4, 3, 8, and so on. So 0, 1, when x is 1, we got 2, when x is 2, we got 4, when x is 3, we got 8, when we got 4 months, we're up to 8, double 8, and you get to 16, and that's already bringing me way off my graph there, and then 5 months will bring me somewhere up there. And then if I graph this line, we got something that looks like that. All right, beautiful. So there's my exponential function, and hopefully I'll find a nice calculator app for you guys, and we can do this on the TI-84 online, or we'll use Desmos, which is a really cool app too that we've used in class. All right, if you take a second and pause here again and read number 5, it's asking, is this a function? Is the relationship a function between the independent and dependent variable? Again, the months is the independent, the thousands of square feet being covered is dependent, and you could always relate. You could always go back to our vertical line test, draw a vertical line anywhere. If you're only touching one time on each line, my line's a little off here, but as long as the graph touches only once on every x, then that means for every x value there's exactly one y value. So in this case, is this a function? And the answer is yes, this is a function. All right, it passes the vertical line test, which is somewhere here. All right, it passes the, we'll call it the VLT, just to abbreviate. All right, so just a quick little recap as you're catching up. We got Lake Victoria. We have f of x equals a times b to the x. This is our exponential function. Okay, the a value is the y-intercept. All right, so hopefully, and we got the y-intercept here at present. So initially, that's how we got the a value of 1,000. B is the growth rate, or how my y values are growing each time the x value is, and it's covered by the water plant, and it's doubling every month, and that's how we got the growth rate. All right, from that we got our equation. To make this table, you could follow, increase your months by 1 and double your area every time you increase, or you can use the equation here, which I think you should know both. All right, so when your numbers get bigger and I ask you, well, what happens after month 22? I really hope that you don't use this table all the way down to 22, because that could get a little annoying and a little tedious. So we'll talk about that in the next couple problems. All right, and now then we're going to make a little graph here. We got the graph manually. You are going to be responsible for making this graph manually, so make sure you get the practice in there. Is this exponential function a function? Yes, it's called an exponential function, so hopefully that gave it away too. But if you do the vertical line test and it passes the vertical line test, then yes, that's another indication that this is a vertical function. All right, so recap of 1 and 5. Let's keep going here. So how much of the lake's surface will be covered at the end of the year? All right, so of a year, hopefully we could put that 1 year is equal to 12 months. So again, so do you want to take this graph or table down to 12 and then give me the y value that goes there? Sure, if you want to. I'm going to say no, don't do that. Hopefully you have a calculator handy. And if you have a calculator handy, then let's use my equation. So f of x equals 1,000 times 2 to the x power. All right, so month 12. So f of 12. So what's going on when x is 12, when the month is 12? So whatever x is goes in there. So f of 12 equals 1,000 times 2 to the 12th power. All right, and then back to that video I'm talking, I keep referencing the basics video. What goes first? All right, please remember that PEMDAS tells you that your exponents goes first. So you need to do 2 to the 12th first, get an answer, and whatever that answer is, and you can multiply that by 1,000, right? Don't do 1,000 times 2 and then raise it to the 12th power. That's incorrect, right? Exponents come first, and then the multiplication. So what is 2 to the 12th? All right, so 2 to the 12th, if you plug this in, you're going to get 2 to the 12th is 4,096. So you got 4,096 times 1,000. You're going to add a couple zeros there, and you're going to get 4,996,000. All right, if you do again 2 to the 12th first, you get 4,096. Multiply by 100, which means you're pretty much just adding 3 zeros. So 4,096,000. So after 1 year, again, the whole lake is 25 million. You've now covered about 4.1 million square feet of this lake. All right, that's getting there. So if you round this to 5 million, roughly, right, you got 5 out of 25. You're already at 1/5, almost 20% of this lake being covered in just a month. So about 20% is being covered. So a little less than 20% is being covered after 1 year. All right, so how long will it take for it to completely cover the lake? All right, so right now I'm telling you that your equation is f of x equals 1,000 times 2 to the x power, right? This will tell you how much of the lake's surface area is covered after x months. Well, now I'm asking you is, well, when is the lake going to cover or be covered by 25 million square feet of this plant? So when will your y value equal 25 million? So here's two equations. So here's y1 and here's y2. And I'm saying y1 and y2 because if you have your graphing calculator, I will show you how to plug this into your graphing calculator. We'll pause and do this with Desmos. Okay, but before I do this with Desmos, I'm going to input these two equations into two separate equations in Desmos. But what I'm asking you to do is find out when this line or this equation will equal this equation. So hence the system of equations. This 1,000 times 2 to the x, right? This is going to be exponential. It's going to grow exponentially. This y equals 25 million is just a horizontal line, right? And then what I'm asking you guys to find is when does my exponential function cross or intersect with this 25 million? And that's exactly what I'm going to be looking on for Desmos. All right, you can do this algebraically, but the math you need for this is Algebra 2. And we'll leave that for the Algebra 2 teachers a couple years from now. All right, but let's see what this has. So I'm going to go to Desmos. All right, so my video is skipping a little bit. I had to do a little adjustments. So in here, you're going to put in 25 million, so y equals 25 million. And then your second equation, you do y equals 1,000 times 2 to the x power. To get the x power, you're going to do shift 6 will give you the exponent, and then you could do 2 to the x power. All right, so you're definitely not going to see what I'm seeing here, and I had to do a little playing around. So this is what I want you to do. On this screen here, you can see that you have some features here, and I want you to click on this graph setting. All right, so here where it got a little tricky. So your x-axis, okay? I did negative, you can do -5, doesn't matter. All right, so I'm only going as far as left -5. And the x, you could do, I mean, just keep in mind, it grows very big, so I don't want you to go too crazy. So let's try, an x value of 30. So from -5 to 30 and see what that does on the graph. So that should help out a little bit. And then when you go to your y-axis, again, you're not really going negative at all. So if you did -1, that's fine. Let's see how that happens. And then the y is going to be a little tricky. So you want to get to 25 million. So I'm going to erase this for a second. You want to get to 25 million. So you could put in 25 million here, but that's going to make exactly 25 million. So I'm going to go a little bit higher. So I'm going to put 30 million. So 30, 1, 2, 3, 1, 2, 3, and you got 30 million. And that's going to change. And in your step, it's going to ask you, what do you really want to count by? So if I'm going to 30 million, counting by ones would be a lot. So we can do a step up. Let's count our y values by 1 million. So 1, 3 zeros, another 3 zeros, and then you can hit this, and then you could click on that again, and you should get back to this graph. All right, so I'm going to erase everything, and I'm going to go to home again, and this is my basic screen, which you guys come to. So one more time. So if I did y equals, my first function was 25 million. 1, 2, 3, 1, 2, 3. Okay. Second equation is y equals, all right, my function 1,000 parentheses, joking parentheses 2, close parentheses, to the x power, shift 6, and you will get an exponent there, and you can put the x there. Alright, so that's the only thing you should probably see on your graph right now. Alright, so I need to adjust my y. So I'm going to adjust my table here. I need to see this 25 million. So you can zoom out, zoom in, all that good stuff on the graph and all that, but that's going to be annoying. So let's go to graph settings, right? So graph settings, okay, I'm going to wrench here, and I'm going to x-axis. Again, I'm in the first quadrant, so I really don't need to go that far back on the x. So I'm going to do -5. This grows pretty quickly, but I still need to get to 25 million. So an x coordinate, you could do 20, 30, 40, you know, like I wouldn't do 100 or 1,000, even though you're traveling to 25 million on the y-axis. It's going to get there very quickly because it's exponentially growing. So I'm just going to do 30 to start, okay? And I know that this is going to help already. So my graph, if you click on this right now, you're going to see that you're from 0. So your graph goes from -5 to 30 on the x-axis. All right, so now let's play with the y-axis. Well, I don't care how low I go, I'm going -10, that's fine. But now I need to get to 25 million. So I know I'm going to see a horizontal. This y equals 25 million is going to be a horizontal line of 25 million. And if you recall, I'm looking for that horizontal line to intersect with the exponential function. So, all right. Well, that horizontal line is 25 million, so I need to get bigger than 25 million. So I'm going to go to 30 million. 1, 2, 3, 1, 2, 3. So 30 million. But that gets very crazy, and just make sure, and then the step here, I don't know if your step pre-filled. If you did a step of 1, then that's going to be a little craziness. So 30 million, I'm going to count by 1 million. My step is going to be by 1 million. 2, 3, and then close it. So now I can see if I just drag my graph just a little bit, or if you zoom down a little bit, okay, you can see exactly your exponential function growing very quickly, right? And this 1 times 10 to the 7th, these are scientific. This is scientific notation, which we'll get more into in exponents packet. But this is 1 times 10 to the 7th power, so you're pretty much adding 7 zeros to this 1 here. All right, so that's 10 million, 20 million, 30 million. All right. And here's my exponential function, and when does it intersect with this? Well, it intersects at about 14.61 times, and a comma, 2.5 times 10 to the 7th, which is 25 million. All right, so when will you reach 25 million? At 14.61 months is the exact answer. So when will this reach? So when x is equal to 14.61 months, or if you want to, or about 15 months if you want to estimate. All right, so that's using Desmos. When the time comes, again, if I could find a cool app on or free app for a TI-84 calculators online, I'll give you guys a separate video for that one. But otherwise, when we get back to school, I'll show you on the graphing calculator how to do that as well. All right, but it's pretty much the same thing. Y1, Y2. We play with our window settings, and then we would do. We've done this in the past. On a graph, we would do second calculate, intersect, enter, and then we find our intersection. Nice and easy, but we'll get there. And then how would the equation change if the initial area covered was 1,500 square feet? So initial area, that is my A value, so A is equal to 1,500. So how would the equation change? Well, it's still doubling, but I'm starting at 1,500 versus 1,000, and it's still doubling, so times 2 to the x power. And then the last one on this one is, well, how would the equation change if the area was tripled every month? So if I have, f of x equals, well, if I had 1,000 initially covered and it tripled, well, then my growth factor is going to be 3 here, and it'll be times 3 to the x power, and it'll just grow a little faster. And while we have it up, why not? Let's take a look at it. Let's make a third equation here. So y equals 1,000 parentheses 3 shift 6 gives me that's the caret button, and then you have 3 to the 6th power, and then that is just joking, 3 to the x power, and then you can see how it changes, and obviously tripling will get there a little faster than doubling. So if we had tripling, if it was tripling the rate, it takes about 14.61 months to cover 25 million. If it was at a triple rate, it'd take only about 9.2 months to cover 25 million square feet of Lake Victoria. So good amount of difference there. All right, and that's how the graphs will look a little different if you were tripling versus starting at or doubling. All right, so that covers 3.2 killer plant strikes Victoria, Lake Victoria. That's part A of this worksheet, but we're about 20 minutes in. What I think you should do is, relook over part A, try part B on your own. I'll make a video of part B as well. But first I would try it on your own first, and then maybe watch the video afterwards and see if your answers match mine. And then there's a part C, D, 3.2. Again, I don't want to rush anything, and then we'll do piece by piece. All right, we'll try to keep these videos up to 20 minutes. I'll upload this onto our drive and on our website. And again, any questions we can either post on Hello Smart. I'll put that blank screen there for you guys, the collaborative screen, or you can post your questions via Google Classroom or email. Any one of those will work. All right, guys. Talk to you soon.